Okay. Now, what we want to do is we want to be able to, so this kind of gets back to our idea of data structures, but there are kind of common data structures that we've dealt with up to this point. And then we have data representation languages. And we've done some of this stuff before. Remind me, in either the 535 class or this class, have we talked about JSON at all?
Remember?
Okay. So we have something called a data representation language. So examples of these are XML and JSON, or our own made up stuff.
Oh, it's like, yeah, XML, this language.
Mm-hmm. CSV is another example. Comma separated values, so you can export an Excel document into CSV format. That's a data representation language where each aspect of it is comma delimited. Okay? So, there are two popular ones in the world today are XML and JSON, and the new kid on the block is JSON. So we're going to just look at JSON today. But XML, you would represent a cave, for example.
Cave, new cave, that cave.
Let me do it this. Let's do this. Start with a blank one. Let's justify that. So if this was XML, you might have something that looks like this. Cave. Exactly. HTML can be created using XML. Becomes a chicken or the egg thing. HTML actually existed before XML. Have you ever seen the thing that says .xhtml? That's XML defined HTML. Because XML is a structured language. HTML looks structured, but the old web browsers were written in such a way to be able to kind of fudge some things. That's why certain websites look different in different web browsers. Because the web browser doesn't necessarily adhere to the standard for HTML. It adheres to an HTML-like standard. So you can put your browser into XHTML mode, where it will reject anything that's not in pure HTML, not in correctly formatted HTML. HTML5 is just the latest version of HTML. It is defined as a standard, as an XML standard. But those are two different things. HTML is an actual language. XML is a tool for building languages. So for something to be XML compliant, it has to be fully supported. The whole language needs to be fully created, as opposed to HTML, which allows you to have bad HTML code that still shows up reasonably in browsers. So I'm just giving a kind of an XML-ish looking representation of our cave. So our cave starts off with a room. And inside that room, we may or may not have a treasure, and we also may have other rooms. So let's say this is a cave with a room with two rooms in it. And each of these rooms yeah, we'll say one treasure. So this is a full representation of a small cave. That is a cave with one room in it. That one room has two more rooms inside of it. And each of those rooms potentially could have more rooms inside of them. Each of those rooms could have more rooms inside of them, so on and so forth. Make sense?
Mm-hmm.
Okay. So that could be an XML structure for our cave. So this would be an example of our cave in XML. We just made up that language, right? Similarly, we could do the same cave represented in a language called Json. So we're going to start off. That's our cave. Inside of this cave, we're going to have a room.
Things commas instead of semicolons?
I believe it's commas, yeah. Well, actually, hold on, let me just double check that real quick. Just so I'm giving us good information. As Safari is crashing.
JavaScript object notation.
Okay. My startup disk is almost full.
What's that mean?
Well, it means my hard drive is almost full. Let's see how almost full it is.
What?
Storage. Ooh, 986 megabytes free.
That doesn't look good.
250. It's not even.
Yeah, so
You have a lot of junk there. Crap.
we got a lot of something.
Mm-hmm.
Oh, hold on.
What's it?
Let me empty the trash. Let's see how much I have now. Two gigabytes.
You have a lot in the trash.
Well, that'll get us through class. I'll empty it out more later. All right, so let's get back to pretty certain it's commas.
Get each.
Yep, okay. So we're going to, I actually need to change this a little bit. So room And what did I say here? I said we had a false and a false. Okay, so both internal ones had actually, I think the last guy does have a semicolon in any one. No, just no comma. Okay.
Oh, no comma.
Yeah. Okay, so this is a representation of the same thing. So this is the XML representation. This is the JSON representation. Or at least a JSON representation. You could also, JSON also supports arrays, but our mini version of JSON is not. Okay, so this is the JSON representation of the same thing. Now, as you look at these two, what would you say about JSON versus XML? Which do you like better?
XML
You like XML? Why?
is easy.
Okay, in what way?
You know when each particular item
Yeah,
ends.
you create yourself. You know what you created, but the idea. The other one also is okay, but
Yeah, we created this one too.
yeah, it's a lot of like
I mean, that one has more
probably
time.
because I love to like create it HTML one. It's more likely look like HTML. It's easier for me.
Okay, so the idea is, so Lauren said this, that there's a lot more writing here, right?
But
This might be, it's verbose, but this might be clear,
that's what we meant.
right? Okay, but there's a lot more writing. But down here, isn't all the necessary information actually in here? We have a room. That room has a treasure, which also has another room, which has a treasure, which also has another room, which has a treasure. So all the real information is stored here in the JSON, where in XML, all that same information is there, but we have like, I mean, aren't these closing tags kind of wastes? I mean, there's a lot of filler in XML.
Closing tags are just so much more clear.
Well, I don't necessarily disagree. At the same time, wouldn't you say this looks more programming-y?
Yeah.
More like a programming language, right? Okay, so really JSON was created by developers for developers. So we're going to call this JSON Mini because we're not going to be dealing with a full implementation of JSON. We'll just have basically our object, our top level object, which is a cave. It's going to start with an opening curly brace and then the closing curly brace. And a cave is a collection of one room.
We didn't even call it cave.
We don't have to in here. It's just the top level. So like I think in our example out here, notice the top level doesn't have anything naming it. We just know that this guy's a cave. Whoever sent it is sending information about a cave. So a cave is a collection of exactly one value, a room object, if you will. What's a room? A room, here's the opening curly brace for room, has a treasure or doesn't have a treasure, and it is a collection of 0, 1, or 2 additional rooms. Does that make sense? Okay. So, what we want to do is we want to build a tool that reads this in and ultimately produces that cave. Does that make sense? Okay. The idea for this would be that when we make this game, we don't want to randomly generate the caves every single time. We want there to be like a reason to play the levels. So if you and I were playing this game, level 1 is going to look the same for both of us. Level 2 will look the same for both of us. Level 3 will look the same for both of us. So that if I get to level 8 and you get to level 4, that truly means that I'm better than you. Not that, well, better than you at the game. Not that I didn't just have better luck. You know, what if I had the 700 room cave that had one treasure in it? It was in room 1. Cha-ching. Level 90, right? Okay, so we want the caves to be equal. So we finally complete this. We're going to generate our caves and ultimately end up storing them as JSON. Okay, so this is a data representation language. We read a data representation language, we need to somehow parse it into an object representation, a data structure. So we're going to read, this is a textual representation of a cave. We want to read this in, interpret it, and actually build the cave that this guy represents. Does that make sense? What we want to try to do?
Okay.
And we're going to write our own. So for right now, I want you to think of this as JSON-esque. So we're not following all the JSON standards here. What I'm basically saying is this is what our language looks like. We made up a language that looks like this, which I think you will find is very, 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 very close to JSON. But we're not going to use any JSON built-in tools. We're going to write our own parser.
But this has Eclipse has built-in JSON.
Java does, but you don't know about that yet. Just like you didn't know about linked lists until I told you they were there. Okay, so we don't know about them yet. So what we're going to do is we want to be able to, well, we're going to do some file I/O. We're going to read stuff in from a file. So we're going to have our cave stored in a file somewhere. Okay? So I'm going to come in here. And we're going to go into our crawler. And I'm going to right click. I'm going to say new. See, this is actually going to go in a weird place too. I'm going to do this a little bit differently just for...
But then how do we do it?
I'll give you the code. So you'll have it.
Oh, you want to make it in terminal?
For a decent reason.
Well, why are you making a terminal and we're typing?
Because you're using Eclipse, and if you want to continue to use Eclipse for this, you really can't build this file in Eclipse because of the way, and I'll show you when I get out to terminal. I don't know why this thing is.
Just go to your...
Well, yeah, I'm kind of concerned about my machine crashing at this point, considering that I'm running out of hard drive space.
Why do you have so much stuff?
It's a good question.
How did you run out so fast? You didn't just use up like half a gigabyte. It just went from 1.78 to 1.33.
Yeah, it's true.
You did not just use up half a gigabyte. That's not reading it right.
You don't think so?
I declare it.
I declare it. How are we doing on our upload?
Not that I know anything about computers, but I don't think that's a problem.
How are we doing on our other upload?
Wait, if you have to restart your computer, then you have to make a new video. You have to save this one first.
Well, I gotta check my
This one's
uploads.
saved? Ooh, that's not good.
Well, no, I have it saved.
Let's say the computer crashes now. Is this one that you're doing right now saved?
Well, probably not.
Believe me, actually, you should say that.
Okay, so this one's processing. Does that mean it finished? Doesn't tell me the length or anything.
Not yet.
Okay, well, let's see. Let's experiment here for a second. We're going to leave that in there.
Maybe you have too much stuff in your Dropbox folder?
I think that's probably definitely true.
What do you intend to do about it?
Delete some stuff maybe?
Will it delete it from the Dropbox to the cloud, or will it just...
This is all recorded. Adobe CS6 hack. Alright.
Wait, but if you delete it from that folder, will it delete it from the cloud too, or no?
Yeah, but I don't need some of this stuff anymore.
You probably cut that part, okay? The hack thing.
Yeah, we're going to be fine. All this stuff is already in iTunes. Oh, there's my Justin Bieber.
Oh my god.
Romantic Evenings.
What is that?
I think it's more songs. All right, let's.
Wait, then what's the purpose of having a Dropbox if you have all this stuff?
I only had those in there when my wife was backing up her computer and we took her off her. Yes, permanently delete.
I don't think the Dropbox will make any changing.
So let's see what I picked up there. Storage. 8 gigs. All right, we're going to call that good for right now. All right, what was I doing?
We're creating JSON.
Oh,
Make sure you click
terminal.
on your terminal.
Terminal.
Where's the their utilities?
Oh, I think you're right.
Or one of those.
All right.
Can we type this too, or just
You can if you want. All I'm doing is I'm going to go into.
don't go fast.
Well, no, yours is going to be in a different place. Yours, where I'm going is not where your stuff will be. I'm going to my. I'm ultimately going to go to my Dropbox folder.
I don't know.
So I'm going to go where my Eclipse workspace is. That's where I'm ultimately going. My Eclipse workspace.
Mine is in my documents folder.
That's
I'll
it.
get to
Well, here, I do it this way. So browse to it wherever it is. So I'm doing this through Finder. So I'm going to go find my Dropbox folder. Here's my Eclipse workspace. Here is our crawler right there. So I'm going to just type cd space and come back out to where the crawler is and just drag that folder in there. That'll give me the full path to it.
Like the full thing, not just bin or source, but like the whole thing.
Yeah, I just go to the whole thing, then we'll be able to get to the stuff that's in it.
Okay. Then
All right,
enter.
so now then enter. So now when you hit ls, it'll show you the stuff that's in there. So here's the situation. In Eclipse, we are working inside the source folder. Here's all of our .javas. Go ahead.
Mm-hmm.
Yours shows source.zip.
That's because I zipped it up to email it to everybody. Okay, so yeah, I also have just a source. Here's the folder. Here's the zipped version of the folder. So when we're in Eclipse, when we're looking at this screen right here, this is all the stuff that's inside that source folder. But when we hit the play button and run it, it goes into the bin folder. So this is where all the compiled stuff is. So if we're going to create a file that we want to be able to use at runtime, because of the nature of Eclipse, we have to put it inside the bin folder. We don't have access to that from within the Eclipse tool. Does that make sense? If we were just writing this by hand in Java, we'd just put everything in the same directory. When we compile the .java files, we'd have the .class files in the same directory. But Eclipse has a file structure is a little different. So I'm actually going to put our cave.dat file inside of the bin directory.
Can I type that too?
Yeah, you can type everything I'm doing now. Yeah, you're not going to like VI.
What do I type then?
I would just do it in text editor if I were you, unless you want to learn about VI.
What's VI?
It's a very old school Unix editor.
Can
Text
I
it.
type it? Or
Yeah, you can type it. It'll work. So VI cave.dat. But just so right off the bat, hit I.
wait, hit enter or I? Wait, what?
Just do it in text edit. All right. So, because I don't want to spend too much time explaining this, so we'll just burn through our time.
VI space
So VI space cave.dat, press enter. Now you're in there. Now this is it's a text, really old school text editor. So to type stuff, you have to be in insert mode. So press I to go into insert mode, then you can type crap. To save, you hit escape to go back into command mode, then colon, WQ to write quit.
Colon WQ to quit.
Yeah, W is write, Q is to quit. Okay, so I'm going to come in here. I'm actually just going to paste in all my code that I had there. So I put it into insert mode first, then pasted it in. But basically what you want to do is you want to create a file named cave.dat in your bin folder. You can do it through text editor or anything like that. It doesn't matter how you get it in there, but that's where I'm putting it. All right, so I'm gonna write this. That'll save it. I'll keep it up in here so we can refer back to it. Now we want to go write the Java code that will read from this file.
Cave.dat 188C written on the bottom.
Escape :W, enter.
Oh.
Yeah, that saved it, and then it shows me the name of the file it saved. All right, so we want to be able to read this file into our code and get the text. Then we'll worry about parsing it. All right, so we're going to go to Java documentation, java.sun.com, and we'll go to Java SE. Then we'll go to Java APIs, Java SE7, and we're going to go to java.io as our package. I'll make this a little bigger. So inside here we have a whole bunch of different things. We have a file input stream. Okay, this allows us to create a file given its name. We also have something called a file reader, which we could also do with its name, but we're going to use the file input stream. So here's the file input stream. Here's the constructor for it. One of the three constructors takes a string as a parameter. So we have three different constructors, right? What's it called when we have more than one method with the same name but a different number and or type of parameters? What's the vocabulary word, the object-oriented vocabulary word for having more than one method with the same name that takes a different number and or type of parameters? This has nothing to do with file input stream. This is a Java thing, and everybody in here has heard the word. Polymorphism. Polymorphism.
Yeah.
That's when you have more than one method with the same name but a different number and or type of parameter. So here's three separate constructors, all capable of building file input streams, but only this last one is the one we want that takes a string name as a parameter. All right, so we're going to go into our code. I'm going to start out actually just in driver for testing this. And I'm going to create a new file input stream, fizz. And this guy's going to be a new file input stream created cave.dat. And it'll know that cave.dat is the guy in that directory because we put it specifically in that directory. Okay, I believe this should work just fine. All right, so now I'm going to highlight file input stream, and it wants me to import java.io file input stream. Okay, now this guy can throw an exception, be a file not found exception. So file not found exception. So we can do the try catch, or we can just say throws exception to cover our butt for right now. Okay, so we create our file input stream. This will allow us to read in from that file one character at a time. We want to be able to read in from that file one string at a time. I'm going to create a buffered reader called input. This guy's going to be a new buffered reader built with an input stream. And the input stream I'm going to pass it is fizz, the file input stream that I created. You can also do this with scanner. Scanner requires a input stream in order to work. But we'll just do it this way. Not overly important for us. Oh, hold on, that requires a reader. Then I'm lying. I'm going to create a scanner. import java.util.scanner. Okay. Buffered reader requires a input stream reader, not an input stream. So we can bypass that by using scanner. So I created my file input stream fizz. That's kind of like equivalent of system.in. System.in is an input stream from our keyboard. Fizz is our input stream from this file. And then we're building our scanner around that. All right, so we'll say string line is equal to fizz, input dot next line, while line is not equal to null, system.out.println line is equal to input dot next line. So this should read in every line of our file and spit it out to the screen, proving that we read it in.
And because there's strings with this two-string stuff,
we
doesn't print memory addresses?
Say this one more time.
Because they're strings and they're two-string stuff, so they don't print memory addresses?
Correct, it'll print out the string that we read in. Okay, did not like, it said file not found exception. Let me check something here real quick. In driver. Well, it should have found it in there, I would think. We did name it cave.dat. And right here, I'm calling it cave.dat.
Do we need to tell it how to get to cave.dat?
Well, it should look in the current folder for it, but it says it can't find it. Let me just make sure I put it in the right place here. And I did. Okay. I don't want to give it to you like that. Can we do // maybe? Let's do that. Let's see if that fixes the problem. Okay, well, this will fix it. I don't want to spend too much time on this. I'm just going to copy the entire path to my file wherever it lives in my system. So if you're on a Windows machine, it would be like // users / blah / desktop / cave.dat. Something like that. Wherever that directory is, wherever it actually lives, copy the entire path to it. And I'll come in here and I'll put that in. So I gave it the full path to where that file lives. Now it should read it in. Well, it did read it in, but it didn't read it in English.
I didn't like the quotation marks.
Yeah.
New language.
So I'm going to do this real quick. I'm going to open up text editor. Oh my gosh. It's going to be indexing for a month. Okay, apps. Open up text edit. New paste, except that's not what I want. I want this guy. I'm going to make that plain text, which I think should fix all the, no, it didn't. It still shows the old ones.
It is. That's right one.
Okay, so I need to replace all those with those.
Wait, how'd you?
I just copied this last one. I copied the thing that's bad, pasted in there. It finds all the ones that match that.
No, but why are we replacing them with? You made it all plain text.
Because
Why does it
no,
not work?
no.
It's still showing the old ASCII value. Like it's showing this fake ASCII value from when I typed it in. It's something from the formatting in Keynote because I copied it from Keynote. So Keynote's using a non-traditional double quote.
Wait, I keep retyping and it's giving me the same. I don't get it.
All right, so now I should be able to go in here.
Oh, that's why it gives us. Okay. Now it's right.
In theory.
Yep.
Okay, so that read it in. Well, regardless, that's just failing because I'm trying to read it in one last time. Is there an input dot has next? Yep, that'll work then. So while input dot has next, we'll read in the line, we'll print out the line. So there's our contents of our file. All right, so we create our file input stream, passed it the entire full path to wherever that file lives. This is not a Java problem, this is an Eclipse problem. Okay, then we create our scanner around that file input stream. And I'll create a variable for holding each line that I read in from it. As long as my scanner has a next line, that's where this input.hasNext is, I'll read in the line, then I'll spit it back out, showing that I can read in that entire file.
What does it give? Just showing that tag space?
I'm just spitting it out. Just proving I read it in from a file into my Java program, now I'm writing it to the screen.
Okay.
That proves I have it.
Okay.
Okay? Now what we want to do is we want to now parse that. So our file currently looks like this. We want to turn this into rooms and with treasures. Okay? So we need to be able to interpret this stuff. So the first thing I'm going to do is I'm going to actually read the entire thing into one big string. So this is going to be becoming a string parsing exercise. All right? So I'm going to do this with line. So I'm going to start line off as the empty string. And then each time through, I'll say line is equal to line concatenated with input.nextLine. Then at the very end, I'll do a system.out.println line. So this code right here literally goes through, reads in from our file, and concatenates every line of our file into this string called line. Then at the very end, I'll just print out whatever line currently holds.
So it's all in one line. Okay.
That make sense?
Yeah.
Okay. All those spaces and stuff are white space. We're going to ignore white space. Okay. In fact, we can even make this an interesting Well, no, that'll take us down. It'll actually be fine in this case, but we're going to ignore it for right now. So what we want to do is we want to take this string and we want to turn it into its objects. So I'm going to create another class in here. Called Parser. Here, we'll call it Json Parser. Even though it's just JSON-esque parser. All right, our JSON parser is going to take in, well, we're going to hold on to a private string. Let's see. Let's just call it JSON. Create a constructor, public JSON parser. This guy will take a string JSON as a parameter, and we'll set this dot JSON equal to the JSON that was passed in. Okay, and then we'll go ahead and prove that that's working by just printing out JSON, this dot JSON. So we haven't done anything new here. We're just going to prove that we can build a JSON parser object, pass in the JSON string, and it'll spit it out to the screen. So inside driver, rather than outputting it here, we're going to say JSON parser JP equals new JSON parser line. So we'll build a new object passing it our JSON string. And that guy will receive it right here, set the field equal to it, and then print out that JSON value. So we should still get the same output displayed to the screen.
Okay.
Okay? So it'll be up to our JSON parser to read in the code. In fact, what we really should do for our JSON parser is pass it the string where the file lives and have the JSON parser read in from the file. That's what we probably should do. That way we don't have to have all this crap out here in driver. So we'll go into JSON parser and say that this guy actually takes in a file name. And then what's he going to do? He's going to create a file input stream. He's going to create all this crap. So I'll get rid of it there. I'll go into JSON parser. Let's get rid of this for right now.
Oh, you okay?
And I'm going to go ahead and throw this inside of a try catch. That way we don't have to throw exceptions here. Actually, I want to do I'm going to do the whole thing instead of a try catch. All right, so we're going to create our file input stream, but what we're going to pass it is whatever file name was, not this. So I'm going to cut all that right now. Say file name here. Out here where we create our JSON parser, we're going to pass it the full path to the file that we want it to parse. So to build a JSON parser, we'll pass it the full name of our cave.dat. That'll come in as file name. We'll create an input stream reader around that, a scanner. We'll create our line, fill it all up, and in the end, we'll set this dot JSON equal to line. And then we'll go ahead and just give ourselves a quick getter. Public string get JSON. We'll return the JSON value. So we should be able to prove that our JSON parser is reading in that file and then spitting it back out to the screen. Okay. So right here, we'll say system.out.println jp.get JSON. So when we created it, it should create the file input stream. It should read the entire file, store it in a variable called JSON, and then I'm asking it for that variable here and printing it out. And it should give me the same output. Okay? So all we've accomplished there is reading stuff in from a file. Now we need to actually take our JSON here, the thing that looks like this, and we need to turn it into rooms and treasures. We need to parse it. Okay? So how are we going to go about doing that? Well, we know that every single thing starts with the opening and closing curly braces, right? And we know that inside the cave, we have a single room. All of that is one room. And inside that room, we are guaranteed to have a single treasure and then 0, 1, or 2 rooms. Why don't we just say 0 or more rooms? That make sense? So what I'm going to do here is we're going to write a little code. Well, let me ask it this way. If I split this guy up on opening curly braces, what would I have? I would have the first part being this. The second part being this. Does that make sense? I start losing context. I would get part 2 being this guy right here, and that doesn't really tell me much about this. So I really need to walk through this one character at a time, building up my tokens. So the very first thing I can do is I can peel away, almost cracking the egg of our cave. Okay, that'll get me to whatever's inside the cave, which is all of that stuff. Okay, so we're going to write some methods in here. I'm going to kind of get you started with this. And then I'm actually going to pause this and put it up there for the assignment. And then I'm going to go on and talk about threads. Okay, so I'm basically giving you just a starting point of your homework assignment. Okay, so what we're going to do here is we're going to create a method in here, private void parse cave.
Why are we making this private?
Because it's all just going to happen inside of a JSON parser. JSON parser is ultimately going to produce a product for us, which will be a cave. Okay, so parse cave does what? It should read past that opening curly brace. Correct? Okay, so we want to get rid of that opening curly brace. So if my text looks like this, I'm going to start reading in until I read an opening curly brace. Once I get that, I want the substring of everything from there to the end.
Minus the end curly brace.
Definitely minus the end curly brace. But let's see if what would happen if we left the end one on for right now. So if I walk and I consume this opening one, now I'm sitting right here. Okay, so this is my current text pointer. So now the next thing I read in, so I'm going to consume this as well as white space until I hit something that's not, so I'll hit this guy right here. This tells me that I'm at my first guy, if you will. When I get to my first guy in cave, what will I hit? I'll hit something called a room. Correct? I'll hit a room, then some white space, potentially white space, it's not required, then a colon, then some white space. Ultimately, I'll hit another opening curly brace. Go ahead.
But our rooms in this text edit quote document, like room starts with lowercase, and our class stuff starts with uppercase.
Well, we'll just have to translate it. I mean, at this point, we're just trying to process a text file. Whenever we see the word room, we'll make new room objects with our uppercase guy. But we can represent it however we want in text.
Okay.
So processing a cave, since we know a cave has exactly one value in it, it has a starting room, will mean reading in everything up to the opening curly brace. Okay? We can assume for the purpose of this assignment that whoever's provided you this text has given you accurate text. Okay? So we're going to walk until we read in our next opening curly brace. So inside of parse cave, we need to skip the opening curly brace. Correct? So we need to read up to and past. Well, let's just read up to the first curly brace. Actually, I'm going to do this. I'm going to have a private variable up top here in Json Parser. It's going to be a private int curpause. And when we do parse cave, we're going to say curpause is equal to 0. We're going to start at bucket 0 in our string, JSON. While this dot JSON dot char at curpause is not equal to an opening curly brace, curpause plus plus. So what does this first line do? This says move to the first curly brace. That's what that while loop does. So that will walk us so that we're sitting right here. Curpause is the guy sitting right on top of that. Now we want to keep walking until we hit another curly brace.
So you want to do it again every time?
Well, right now we're sitting on that curly brace.
Second
Correct?
curly brace, and
So I'm going to say curpause plus plus. That'll move us past that first curly brace. Then move to the second curly brace. All right. So at the end of that second while loop, we should be sitting right here. And when we're sitting right here, we know that this is a room to process. Does that make sense? So we're going to create another method here. Private void. For right now, I'm making these void. You might change this in your homework. Private void parse room. Okay, and then just for right now, I'll just put in the starting point. I'm going to do system.out.println. Actually, let me just do it this way. I'll say for int I is equal to 0, for I is equal to this dot curpause, I is less than this dot JSON dot length, I plus plus, system.out.print, this dot JSON dot char at I. So when we call that, it should print out literally everything from here to the end. skipping just this first part, proving that we positioned ourselves correctly. That make sense? All right, so I'm going to go ahead and I'm just going to create a simple little method called parse. Actually, we already have parseCave. That basically does that. So here inside of driver, we create our JSON parser. Then I'll say jp dot. Oh, I made it. That's why I wanted to make it. I'll go ahead and make this public. I was going to make a public parse method, but just for right now, let's just make this public. So we'll make parseCave public, but all the rest of the things happen inside of here. So parseCave will be public so that when we're out in driver, we can say jp.parseCave. And that should call the parseCave method. ParseCave method does what? It positions past the opening curly brace and then positions us on the second opening curly brace. That is the opening curly brace, that is the first room. Okay? Then we'll call parse room. This guy does. Oh, here's parseCave. So we need to call this dot parse room. So after we know we're positioned, we're going to call parse room, and this should actually spit some stuff out to the screen. That is everything from here on. So the very first thing we should see is an opening curly brace, then the word treasure. Opening curly brace, there's our treasure. Okay, so now we're positioned at the very first room. That make sense? Okay. Now, what do we read in next? Well, we're processing a room. A room reads in treasure, true or false, and then it reads in the rest of the rooms that are exits. Make sense? So what you're to do for your homework is, given an input that looks like this, follows this format. I'm going to give you the code as a starting point. Given that input, you should read it in, parse it, and build the necessary rooms. This should probably require you to build a second constructor for room. Hint, hint. Polymorphism. Hint, hint. You have a second constructor for room. That second constructor for room maybe takes in whether or not this room has treasure. It might also take in the number of exits this room has and information about each of those rooms. Something like that. Okay? So you can decide how you actually want to implement that. So let me save all this. Now let's go ahead and put it up. And I'll make sure that you understand the assignment.
I actually don't have any typos today.
Good. There's still time. All right.
Why we need that compiler? I mean, you compile it through terminal. Should we do it the same?
You won't have to. Actually, all you'll have to do is go in and change the full path. You'll have to just change this.
Okay.
I'm giving you that file. That file will be in the zip file I gave you. It'll be inside the bin directory.
So we don't need to create another.
You don't have to create it. All you have to do is go and find out where your bin directory lives and give it the full path to that. So when you run your program right off the bat, you should get output that looks like mine.
Okay.
So as soon as you hit play, you know that you have this line right when your output looks like this. Then you know you're ready to start working on your homework.
So in homework, yeah, I know. In homework assignment, we need to create.
I'm about to write it.
Okay.
Yeah, you'll see me typing it. I'm just going to zip up the code that way I don't forget. Okay, so we're going into here's crawler. Okay, I'm going to actually give you the entire crawler folder for this one since I have that stuff in the bin directory. Okay, so crawler.zip. So now we'll go out here. We'll go to I'll tell you right off the bat, there are better ways of going about the parsing than I've currently shown you. So this is a pretty ghetto way of going about it, but it'll be a good algorithm practice. All right, so we're going to go here. So I think we're in unit 3 now, right? Yep. Add content, Dropbox. Homework number 5, right?
Mm-hmm.
Expand the attached code for our crawler game such that it reads in the cave.dat file and parses it into an actual cave object. This functionality should allow us to create caves from a JSON-like text document rather than grow caves randomly like we are doing now. In the end, you should be able to run the program and play our game in the exact cave that the file, well, exact cave that cave.dat represented. You only need to support one cave in this version of the program. So you will not need to declare a winner or move to another cave. You can even just let your program crash. As long as you read in the cave.dat file and we can walk through that cave and collect treasure. Make sense?
So we are.
I'll go ahead and attach the code.
Why is it like .dat? Like, is that just a text file that we're sticking in? Does it have to be .dat?
No, you can name it .bingo if you wanted to. Yeah, just, yeah, whatever you, we just told it what its name is. Yeah, that extension doesn't mean anything.
Oh.
Yeah, just historically .dat is a data file.
So,
Like .txt is a text file. Like .doc is a Word file.
so if you name it .bingo, then what's it tell you in the what's that? If you go into,
It won't know what it is. It'll put just a generic file picture next to it.
oh, this one says kind of like a .dat file. So if it's just anything, it's just
Right, yeah, .bingo, it'll say, please choose the program you want to try to open this with. Let's see, so I need to go to spaces. there's our crawler.zip. Choose. Upload. There you go. And this is due next Monday. Okay.
What about the report?
Yep, we're doing the report now. Report number 5. Write a 2 to 3 page paper. Now, are you sure we did not talk about JSON and XML in the 535 class?
Positive.
Positive, okay. Write a 2 to 3 page paper describing XML and JSON. What are they? Why do we need them? Which is better? Well, let's see, which are there certain applications that favor one of these over the other? Explain. What is SOAP
So,
as XML is concerned? Finally, what advantages does JSON have over XML and vice versa? Make sense? Write a 2 to 3 page paper describing XML and JSON. What are they? Why do we need them? Are there certain applications that favor one of these over the other? Explain. What is SOAP? What advantage does JSON have over XML and vice versa? Make sense? Okay. Okay, so those are the 2 assignments due next Monday. So now, as long as there's no questions about that, I want to start talking about threads for the rest of today because we're going to incorporate them into our code next time. Make sense?
mm-hmm.
Okay, so let's start off by talking about threads. A thread. A thread is a single entity of execution which lives within a process. Now, let me try to explain this through some code. So I'm going to go ahead and I'm going to close all of this stuff, and I'm going to create a brand new project called thread test or something. So I'll create a new Java project. We'll call this guy thread test. And inside that, we'll create a driver. Always do our hello world to start the deal off. Make sure everything's firing. Okay, there's our hello world. Works. Okay. Now, what I want to do here is I'm going to create another little method in here. So we're going to create a static void blah method. And this method is going to say while true, do nothing. Then we'll say done.
Isn't it not going to reach done because?
Absolutely, it's not going to reach done. All right, so when we run our program, all programs begin and end with main, right? So it's going to start off right here. It'll print out here. Then it's going to call blah, this method we wrote. And what does blah do? It's an infinite loop that does nothing. And as soon as that's done, as soon as that infinite loop is done, we're going to print out the word done. So I run my program here. It prints out here, and I never see done. Right? Okay. This line right here is said to block this line right here.
Okay.
That makes sense? And if we want to see this a little bit, let's have it be a little bit more reasonable. So we'll have blah print out all the numbers between 0 and 9. Then we'll see done. That'll prove that this guy blocks. So we get to this line, it prints out here. Then this line changes where the program is currently executing. That is, it blocks, so we do not get to this line until this guy finishes. So we'll say here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we'll say done. Make sense?
One more time, please. So you're saying this one prints.
This guy
something.
prevents us from getting to this line.
Okay.
We don't get to this line until after this guy's printed all of his numbers.
Okay.
Okay, so this is called a line that blocks.
Mm-hmm.
Now let's just say that we didn't want this line to block. Let's say this is really important work. This is important work over here. But sometimes when important work gets done, we need to send somebody else off to do the work. And they report back when they're done, right? This is the use of threads. So let's say I'm the boss. If I'm the boss at a business, I might say, hey, here, go do some work. And then I'm going to go and I'm going to make a phone call. Well, I don't want to have to wait until this guy comes back having finished all of his work before I can make my phone call. I should be able to make my phone call right now while he's off doing his thing. Make sense?
Mm-hmm.
Okay, so as we've currently written Java program, we don't have a way of simulating that. It seems so simple to us, but we don't have a way of doing that at this point. Right now, I can't make my phone call until that guy's done working. So that's where threads come in. So we're going to create a quick thread. So I'm going to create a new class. And I like calling my threads worker bees. Okay, so I'm going to, it's a good way to name them initially. So I'm going to create my class called worker bee, and I'm going to say this guy extends thread. Okay, there already exists a class called thread. It's in java.lang, and it has within it the magic for spawning off a thread.
Okay.
Okay, and what I'm going to do in here, huh?
We're actually using from Java.
No, we're writing our own. We're just using the one that's built in does nothing. It just has the magical tricks in it to make threads start. We're making our own guy that is a thread so that he does the things that we want this particular thread to do.
Why do we have to extend thread?
because we need thread's magic trick for actually creating a second process. If we didn't have this, then we would be stuck with things that block still. So the thread class has that magic in it for us, for the boss to send this guy off and work, and then release us to do what we want to do. It knows how to spawn that off. So we're going to create a public void run method. So the thread class has this method in it already, but it does nothing.
Wait, but if we're in a class worker B, doesn't it have to be like public worker B? And then...
No, this isn't my constructor. This is just a class. We're getting there. Yeah, just follow. You'll get it. Okay, I'm not writing a constructor. This guy gets no constructor. It's a no argument constructor that's provided for me. That's why I don't have one called worker B. This is just a plain Jane method called run that returns nothing and is public. Okay? So this guy actually comes with thread. So I don't even have to write this guy. But thread provides me public void run that does nothing. The reason is this thread implements an interface called runnable. So if I show you that real quick, do I still have the Java documentation open? Probably not. Java.sun.com. Now, why did like half my class leave?
They were talking about their thing on the computer.
Oh, well, that makes sense. All right. Be funny. We should do a quiz. All right. So.
Was here with your points?
Like, oh, you guys just missed a quiz. All right.
Just tell them that when they question.
No, but we actually had to have had a quiz in order for it to be believable. I think Habib would crack. Wouldn't be able to keep a straight face.
Email us something. Make we should list the first 5 things in the Java list thing right there.
All right, so I'm going to go into java.lang, which we're already in. I'm going to go down to thread. Well, actually, I'm going to go into java.lang. Then we're going to go into thread. And we're going to see this guy implement something called runnable. See it now? So he implements runnable. So he is an object. He implements an interface called runnable. Now, interfaces are another special thing we haven't really messed with. We're not really going to get into interfaces too much other than me introducing it here. An interface is like almost like a skeleton class that when something implements an interface, it dictates what methods that something must implement. So for instance, if you're in the grocery store, every single box, whatever you find, you can go through the grocery store, you can pick up anything that you find in any shelf, they'll all have a UPC code on it, right? Mm-hmm. That you can scan. They can scan up at the register. So somebody somewhere decided, you know what? We need to have an interface that says that anything that is sold in a grocery store, anything that's sold in any kind of store, has to have a UPC symbol on it. That way we can scan it at the register.
Except produce, which has PLU codes.
Well, you get what I'm saying. Yeah, so the idea is that the people who made the registers, like, you know, she works at Sendix. So Sendix did not make their own.
I saw it there.
You've seen me there.
Yeah.
Oh,
so Sendix does not make their own registers. Sendix buys their registers for hundreds and hundreds and hundreds of dollars from some company that makes store registers, right? Well, that company can only make store registers to go into a zillion different stores if they can count on all the products in those stores having UPC codes. Okay, so somebody made an interface, somebody made a rule that says anything that goes in a store, anything that's sellable in a store must have a UPC code in it. Anything that's runnable must have a public void run method. Mm-hmm. Okay? So similar.
So would be voids then?
Huh?
Then our threads have to void stuff in them? Or?
Well, we did. Every thread must implement a method called public void run.
Oh, so anything in the public void run does not have a void.
Right. Anything in this is what the thread does when it runs. Okay? So a thread, the generic thread, has a method like this that does nothing. That's a pretty useless thread. So we can create a generic thread and we can tell that thread to go, and it will literally spawn off a secondary thread that does nothing. Waste of time. Probably like half the employees in Sendix.
That is true.
Okay, so in any case, that's what an interface is for. Interface is a kind of a police officer that polices things that are supposed to implement these things, rather than it just breaking. So if you don't implement a interface, you just won't get yelled at by Java. Okay, so the idea would be if there wasn't a standard in the grocery store, instead they just let products come in and however the place wanted to package their products and mark them for sale and all that stuff. People just did it. Most companies would probably adhere to the pseudo standard, right? But any company that didn't would come in, and then what would happen when somebody came up to the register to have it scanned, it just wouldn't be scannable, and they wouldn't be able to buy it.
And then you have to go do a price check, and you have to stand there and wait.
Yeah, whatever it is. So that type of thing. So the idea is that interfaces are there to police us to do this stuff. So we're going to write this run method, and what are we going to do inside this run method? Well, we're going to go back and we're going to do our while true, do nothing. So again, we're going to put our infinite loop in there, right? Now, remember, that guy used to block us. Okay? So when we did this out in driver, when we had our infinite while loop down here, so I'll just put it back, while true, when we ran our program like this, it would print out here, then it would call the method down here that says while true, and it would block us from ever getting to this done.
But if you have two threads and you have a system that have to print in each one, then which one doesn't print first?
Well, then it becomes a race, and you'll see that in a second. Okay, but right now we're going to see that this thing blocks, just like we did before. So we're just reminding ourselves. We see here, it's stuck in the infinite while loop, never says done. Now what we're going to do is instead of calling this local method blah, we're going to build one of our threads. So we're going to create a worker B, WB, is equal to a new worker B. This is the no argument constructor that's provided for us if we don't write our own. And then what we're going to do is we're going to say WB.start. This starts that thread. This is the magical method that we did not write. Inside worker B, we did not write a method called start. That method was provided to us by thread, and it's the magical method that knows how to actually manipulate the operating system and spawn off a new process. All right? So we're going to print out here. We're going to create a brand new worker B. We're going to tell that worker B to go start working. And then we're going to see that done still shows up. So by calling it this way, huh? We're not even using this anymore.
Oh, okay.
Yeah, we're not using that anymore. Now instead of doing our work locally, we're sending our worker B out to do that work.
So
okay?
It's not looking for the static void blah, right?
Well, I never called it.
I mean, in my case, it's not even looking at that.
Well,
Just
but the
here
thing is,
now.
I can leave this here. It's not going to hurt anything.
Yeah, I know.
Because I'm never calling it from up here.
Yeah, that's what I'm saying.
Okay, all programs begin and end with main. So I'm going to print out here. I'm going to create a worker B. I'm going to tell that worker B to get to work. Then I'm going to print out done. And we're going to see that my program prints out here, then done. Okay, we won't see anything from our worker B because he's just sitting there wasting his time. Okay? So I'll run this. There's my here, there's my done. That worker B's cooking.
If we right away put the extend the thread from the driver, does it work the same?
Extends. I'm going to guess no because I don't.
Yeah, the driver, you.
Well, tell me what you want me to type. You want to say this guy extends thread?
Yeah.
Okay, well, so what are you trying to accomplish with that?
Do not like create a worker B class.
Well, you would have to then create instances of this guy. So I could say this guy extends thread. I can then put inside here a run method. But then here I would have to create a driver D equals new driver. I would still have to create an instance of that guy to start him.
Okay.
So it probably doesn't make a whole lot of sense for that guy to extend thread since he's in a static context.
Can we use blah method inside the main method and like later we can call for done.
Can you use blah?
Yeah.
What do you want to do with it?
No, like after a while we can, like ask to print done. Here and they can, we can use any number and then we can call for done.
Well, but why do you want to use blah rather than our worker bee? I mean, the worker bee, I'm showing you how to make two things happen at once, essentially. So before, when we call blah, which has the exact same code in it as our worker bee has, right? When I call blah, it blocks. So right now it'll say here, and it'll never say done. Because all this is happening inside of the same thread. So that means that this one thread is having to wait for blah to finish before it gets to here. And this guy never finishes. But blah never finishes. I mean, understand blah is an infinite loop right now.
Okay.
This guy never, ever, 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 ever finishes.
Okay.
Yeah, like we use like while and then we can use do, so like it will print some done.
Well, okay. I mean,
And then
wait,
if it is a condition.
don't confuse it. Understand what we're just trying to show a very simple concept here.
Okay.
The concept is if I do something linearly like this inside of a single thread, a method like this has to finish before I get to this line, no matter what this guy does. This guy could print out the numbers 1 through 10 like we did a few minutes ago. Okay, doesn't matter what this guy does. This guy has to do his thing and finish before we ever get to this line right here. Okay, well, let's just say that this guy right here is doing a lot of work. So this gets back to our example of the boss says, hey, I need you to go pick something up at the grocery store because I got to make a phone call. Well, it would be stupid in real life if the boss literally had to wait for the person to come back from the grocery store in order to make their phone call. We want to be able to send this guy off to do his work, and then we can make our phone call immediately. And that's where this worker bee comes in. So we create our thread, we tell that thread to start, and he gets going, allowing us to make our phone call right away. That guy's still in the background working right now because he's in an infinite loop. Here's our worker bee. This is what he does all day long. He sits there and does nothing, but he's doing something while he's doing nothing. Go ahead.
So in worker bee, in public void run, instead of saying while true, can you put driver.blah, and then will it still run this?
Oh, I see what you wanted to say.
So that way you can put the other thing that you want to happen in driver, and then
This will work.
Okay.
Because what is driver.blah? Driver.blah is that code.
Well, I was just wondering if it can pull it from driver.
Yeah, it's a class method.
Okay.
But it is calling it from a different thread. So yeah, that's a good, interesting point. Okay, so now gets back in our last couple of minutes here. What Lauren was asking before. Inside of run, what I'm going to do is I'm going to say for int I is equal to 0, I is less than 100, I plus plus, system.out.println I. Okay? So that's what my worker bee does now. He prints out the numbers 0 through 99. Okay? Spits them out to the screen.
And what if you do just go on?
Okay? So now I'm going to print out here. Then I'm going to tell my worker bee to go get to work printing out the numbers between 0 and 99. And then I'm going to print out done. But we're going to see very, very, very likely done is going to print out somewhere in the middle of those numbers. Possibly even before the numbers start. It won't print out at the very end. Or at least it probably won't print out at the very end. If it does, we'll make the 100 be 1,000 or something. Yeah, see, it printed out actually before we even got into that loop.
Why?
Well, because he didn't have to wait.
Oh,
He didn't have to wait for this guy. This guy was off going to the grocery store. Okay? Well, we made our phone call.
okay.
That make sense?
Yeah.
So that's the point of having threads. Now, interestingly, we can also create multiple threads.
Yeah, like it is executing 2 threads at the same time.
Yep. The main thread. Every program has one thread, the main thread, and then we just spawned off a second thread. So 2 threads are executing, I'm going to say pseudo at the same time. because a thread is a lightweight process, and our Java program is getting an amount of CPU time. Okay? Well, when we have one program with multiple threads in it, those threads are all sharing the CPU time that that one program is getting. So realistically, you probably don't have two things literally happening at once. They're still happening linearly, but they're each getting their little bit of CPU time.
Yeah,
So
like, can we get
it's as if they're happening at the same time. It's as if they're happening at the same time.
No, like, can we get deadlock while like executing two threads?
Well, it depends on what the threads are doing. You could get deadlock if the threads are doing things that are reliant on each other. But in this case, the threads are just printing crap to the screen. They're very much independent of each other. But if we had the two threads working on, building a jet or something like that, then we could have an issue where, you got to make sure the wings are on before you try to test fly it. that kind of thing. Well, now I created two more threads, so I'll say WB2.start and WB3.start. Okay, so now we have three separate worker bees, each printing out the numbers between 0 and 99, all while we go in here and print out here, then done. There should be at least some overlap somewhere in here. Okay, well, there's the done happened before the
Third.
Yeah, before the third guy. We can create overlap if we just make this number bigger. Here, let's just make it 100,000. It might be hard for us to find it, but there will be overlap then. It'll have to switch between those numbers. So somewhere in there, there's going to be, switching between threads a couple different places based on the amount of time.
So
Okay, well, so anyways, that's the high level of how threads work.
I have a question. Why we need the threads?
Well, that's where we're going with for next class.
Okay.
Because we're going to turn our program, our cave crawler, into an online adventure where we can have multiple players playing at once. And so we're going to have to do some network programming next time too, opening up socket connections and things like that. Well, if somebody's connecting to your game, when I go to connect, if you're the authenticator, here, let's use Amazon as an example. If I connect to Amazon and I'm logging into Amazon, can you still log into Amazon and buy something?
Yeah.
Yeah. Me logging in doesn't prevent you from logging in, right? So I'm working in my own little authentication thread. So we're going to have the same thing happen with our game. Our game's going to have a game server. We're going to connect to it, and what it's immediately going to do is it's going to push us over here and say, okay, go ahead and authenticate with this guy because I have to wait for somebody else to knock at the door in case somebody else wants to log in at the same time. Okay, so we're going to work with some network programming and threads next time. Make sense? Questions, comments, concerns, bribes?
Like how we can, threads normally use in the games. Okay, like we have the pictures in the games, so like how we can make the threads by using from other sources. Like I want to take some file from my folder to view the threads while executing.
Okay, well, so are you talking about when you have a video game that is graphical?
Yeah, graphical. Yeah, so like it's used multiple threads at the same time.
Sure, but this is actually why, like a lot of video games, most of the processing power is happening locally. So if you play Xbox or something, Xbox Live is the communication channel between those games, but the game is your 60 gigabyte install of Madden that you have locally on your machine. So all those graphics and all that stuff is all happening locally. Those are not being transferred over the network. So your game is being played locally on your machine, and then if you want to be able to go and check email and stuff like that while you're playing your game, now that's the operating system itself that's running your video game inside of one process and your email inside of another process, and when you minimize one and go to the other, the one that's in the foreground is getting the most CPU time. I guess what I'm saying is operating systems employ threads just like we are using, and they employ threads just like we're using them here. So there's kind of two different levels of it. We talked about this in the operating systems class, but the two different levels are we can have thread level concurrency or we can have process level concurrency. So process level concurrency would say we literally have two programs running at the same time. Thread level concurrency says we have one program, but that one program has subdivided itself into multiple threads. When you have two programs running at once, each of those programs gets their own independent and complete chunk of CPU time. When you have one program running with multiple threads, all those threads share that one program CPU time. So it's accomplishing the same thing, just threads are lighter weight. Threads are built for things like this, where sometimes like a program, like a big program like Microsoft Office or something like that, might actually be running as multiple processes, as well as multiple threads. Some aspects of it are going to be multi-threaded, other aspects of it are going to be multi-processed. Okay, well, we're already over, so let's stop there. And I'll see everybody next